In a group of 25 people, there are 3 swimmers, 6 swimmers. There are 6 swimmers. And there are 8 cyclists. And there are 11 runners. 11 runners. Each person competes in only one of these sports. A team of 7 people is selected randomly. Without restriction will be 25C7. Without order them, if it is ordered, will be 25P7. A team of 7 people is selected from these 25 people to take part in a competition. Find the number of different ways in which the team of 7 can be selected if it consists of exactly 1 swimmer. I'd like to do it like this. You have to take exactly 1 swimmer. So will be 1 for any of cases. Maybe I don't know how many cases till now. So I write here 1, 1, 1. If needed, will complete. If it is not needed, will remove. 1 swimmer exactly. So there is no change for these values. At least 4. At least 4, maybe 4 or more. 4, 5, 6, and so on. At least 4. Leave this. At most 2. At most 2, maybe 2 or 1 or 0. At most. So look at the first case. If 1 from swimmers and 4 from the cyclist, how many left to complete a group of 7? 1 plus 4 is 5, so I need 2. It's correct because it's written at most 2 from the nurse. If we increase the number of cyclists to be 5, so how many needed for the nurse? 1 plus 5, 6, still only 1 left. If we increase 5 to be 6, 1 plus 6 is 7, so we have to take 0. I think now there is no more cases. Let's now write our answer. Will be like this. 6 will select 1 times. 8 will select 4 times. 11 will select 2 plus second case. 6 select 1 times. 8 select 5 times. 11 take 1 plus. 6C1 times 8C6 times 11C0 plus, and simplify your answer. Calculate the first case, second case, and the third case, then add all together. If we take the first case, second case, third case, you will get the total in summation. If you'd like to take them separately, will be 23100 plus 3696 plus 168. So the final answer is 269,269,64. For another competition, a team of 9 people consists of 2 swimmers, 2 from swimmers, and 3 from the cyclist, and 4 for the runners. There are now 9. The team members stand in a line for a photo. How many different arrangements are there of 9 people if the swimmers stand together, the cyclists stand together, the runner stand together? For together means deal with it as a 1 card or a 1 member. So we have 3. In how many ways we can rearrange 3 in a line? It's 3 factorial. Then start to rearrange each team or a group in between. So for 2 swimmers, it's 2 factorial. For 3 cyclists, it's 3 factorial. For the 4 runners, it's 4 factorial. Find all in between multiplication. You can find in how many ways we can rearrange where is each same together. So the final answer will be 1728. Part C, how many different arrangements are there of 9 people if none of the cyclists stand next to each other? Let me explain this question by many ways. I prefer this method. I name it gap method. Firstly, we'll rearrange 2, 3, and 4. There are 2s, there are 4 2s, 3 cyclists, and 4 runners, 4 runners. None of the cyclists stand next to each other. This means no together, no 3 together, no 4 together. So I will rearrange swimmers and cyclists first. How many? 1, 2, 3, 4, 5. So by how many ways we can rearrange swimmers and cyclists in between? It's 5, so will be 5 factorial. Okay. For 5 factorial, 1, 2, 3, 4, 5. What about these 4? To rearrange 4 in between, how many gaps included? Sorry, I'll check the numbers of members here. 2 swimmers, collect 3, so, okay, and 4 runners. Okay, correct. Now we'll look at the spaces. How many? It's 2, 3, 4, 9, correct. So we'll rearrange. It's written cyclist. Oh, it's my mistake. I look at the question many times. He asked about the cyclist. So I have to rearrange swimmers and the runners. So it's 4 and the 2, it's 6. Let's now rearrange the cyclist in between. How many spaces provided? 1, 2, 3, 4, 5, 6, 7. Each time it's n plus 1. So if you rearrange 6, so the gaps will be 7. For the first one, how many? Firstly, I rearrange 6 factorial, which is 4 and 6, 4 and 2. How many gaps there are? 7. If we take the first one, how many places available? It's 7 places. So we'll multiply by 7. Second one, how many places left? There are 6. The third one, how many places left? It's 5. Let's now calculate this value. It's 6 factorial multiplied by 7, multiplied by 6, multiplied by 5. So the answer 151200. The next one, if there are 6 factorial, how many spaces? There are 7. I will select 3 different places from these 7. After that, we'll rearrange in between. See, try to find this answer. It's 6 factorial multiplied by 7c3 multiplied by 3 factorial. So the answer 151200. 151200. Third way, we can say 6 factorial instead of write like this. It's 7p3 because included selection and arrangement will be 151200. That's it. Thank you.